In this video, we're going to look at classification with scikit-learn. Scikit-learn is a machine learning library for Python, and we'll look at classification when the training data does not fit in memory, sometimes called out of core. We'll also look at the hashing trick to create feature vectors. We're going to base the code off some code in the scikit-learn documentation, but we simplified it and narrowed it down to just look at the stuff that we're interested in. And we're going to use our data set we used before so we can compare how well it does. So we're not going to use this Reuters data set. We're going to use the 20 newsgroups data set from before. Since we are basing it off this code, we have some license information here just to keep our ducks in a row. So the first thing we do is we get the data like we did before. We have data, file names, target names. And here's where we do something a little different. We define a function that returns a mini batch. So it just returns a little bit of the data. And this is where we get the out of core, is that we don't have to store all of it in memory. We can just get a little bit at a time. In this case, we're going to get 32 records at a time. So we have this function called getBatch that takes a data index, which is a pointer to our current record we're on, and text, which is the data set. This text could be a file or a table, just some pointer to where we know to go get the data. Okay, so we first start off with a couple empty lists for the text and the label, and we loop for t and range batch size. We're going to go through 32 times. When we get to the end, we're going to return empty, which has the effect that the algorithm will know to stop training. You could continue to loop through the data. Some algorithms are good that way. You need to see the data multiple times to update parameters. In this case, we'll just return nothing so it knows to stop. So if we don't stop and we actually still have data, then we append the text and we update the data index. And then when we return the text, the label, and these are a list of texts, the list of labels, and the current data index. So we initially start off with the data index at 0. The next step is we're going to import our stuff from sklearn. And one thing we're going to use is a hashing vectorizer. This is the hashing trick. So instead of creating a dictionary and associating each word with an index I, so like the word dog may have index 157, the index for a word W, dog, is computed using a hashing function, H. So you get the index equals the hashing function with the word, and then you mod that with the number of features so you stay within your number of features. And so the hashing function is sometimes things like take the first letter, convert it to a number, 1 through 26, and multiply that by 16, or take the next letter into the power of 7, some kind of function that converts a word into a big integer that is then modded down into your range. And so in this case, our num features is 2 to the 18, some very large thing, and we can do this because we can also use a sparse representation. So instead of representing the whole vector, we just represent the elements that are non-zero. Looking at the classes, we have 20 classes, and we're going to use 4 different classifiers. So we have the stochastic gradient descent classifier, which is really an SVM, support vector machine. We have the perceptron. We have a multinomial naive Bayes. Multinomial means it ignores non-occurring features. There's a passive aggressive algorithm that's good for large scale learning, and I've seen that work well in the past. So those are our 4 classifiers. And now, like we did before, we need to get a set of examples for testing so we can estimate accuracy. So we're going to use the testing number of test documents to be 96, 3 times batch size. And so what we do is we loop through 3 times. At each time we get 32 records, and the data index gets returned, and we pass it back in the next time so it knows where to restart because we're doing out of core. And text could be, in some cases, a file pointer. In your file, go to this location, data index, IDX. So we're going to do it 3 times. So we have then X test text is a list of 96 texts, and Y test is a list of 96 labels. And we take our test text and transform it using our vectorizer. Now we create some structure to store statistics. We're going to do this because we want to see how our algorithm does over time. We're going to use a while loop, and we're going to say while we're still getting data. Recall that our getBatch function returns an empty list when it reaches the end. So we first call getBatch to get some data, and then the while loop is while you still have data, while the list has a length greater than 0. We update loop count, and we vectorize the train data we got, and then we loop through each of the 4 classifiers call partial fit, which says train on this bit of data. And then we update the statistics, seeing how well it's doing on the test set. And we do that for each classifier, and then we loop through this whole loop until we've gone through all of the data. This line at the bottom is important to keep it from being an infinite loop, is you get the next set of data, update data index, and this gives it a chance to have X trained text be an empty list so that the loop would terminate. So when we run this, and again, like the last video, I ran this already so you wouldn't have to wait around with me. You get a divide by zero warning here. And that's because we're doing training with batches, and each batch is of 32, and each batch may not have each of the labels in it because there's 20 different labels. See how it does. Call it every 30 iterations. We are outputting how it's doing for each classifier, and we're only going through one epoch. What epoch means is one pass through the data. So we're doing one epoch. We're called it returns an empty list when it gets to the end. Through our one epoch, we see how it does over time as it sees more and more data. And we see that it gets up to 90% for the naive Bayes, which is pretty good. It's better than we saw before, which was 77%. We're using that vectorizer and a different toolkit. In this case, scikit learn instead of TextBlob, which uses NLTK. But of course, there's a lot of hyperparameters you can tune. So the perceptron doesn't do as well. The SVM, the stochastic gradient descent, does okay. And the passive aggressive does pretty well too. And we actually have this plotted as well. So what we have here is if you do matplotlib inline, tells Jupyter that I want to see this graph inline, create a plot function with plot.plot. Here is the result. You see that things get better over time, and naive Bayes is generally doing better. So in this chapter, we first started with an introduction to text classification. Then we saw text classification in TextBlob. And in this video, we took it a step further and showed how to do text classification when all of your data does not fit in memory. Now, in this case, the data did fit in memory, but we wanted to do the same data as before so we could kind of get a comparison. But if your data does not fit in memory, you'll use this get batch function to get a batch one at a time and feed them to your algorithm.